So again, this would be a dehydration synthesis, otherwise known as a condensation, because water is being produced and a larger organic compound has been synthesized. So for number 12, we have two left here. Number 12, we're going to take an aldehyde, and we're going to make isopropyl butanoate. So you need to know that an aldehyde, we're starting here, and an isopropyl butanoate is an ester. So we're going to do this in two steps. We're going to turn our aldehyde into an acid and our acid into an ester. So how do we know what aldehyde we're starting with? Well, our parent is a butanoate, which means we have to start with butanal. So there's my butanal there. And according to your pathway chart, we have to oxidize it. So we'll use the permanganate ion again. And so what we're going to do here is, this is an H. We're going to take some of that O and we're going to insert it in there. So on the other side, we will make our butanoic acid. That's where my O goes, and my H. So now I have butanoic acid. All right, so in terms of types of reactions, we definitely have a controlled oxidation because we added some O slowly, and we also have an addition because we put in an oxygen atom that was not there before. So the second step now is we're going to take that butanoic acid, and now when you go to your pathway chart, what we need to do to make an ester, which is going to be an esterification, is to add an alcohol. So what alcohol do we add? Well, you go back to the name of your compound, and it's isopropyl butanoate. So we're going to add isopropanol. So again, we're going to remove the OH from the parent. We're going to remove the H from the alcohol because that's what it says here that we need to do. So to make our ester, we remove the OH from the parent acid. So on the other side, we know we're going to produce water, and that open bond here is going to pick up this open bond here. So now we're going to put on the isopropyl onto the acid, and now we have isopropyl butanoate. According to our chart on conditions, when you add an alcohol, you need concentrated sulfuric acid. And now looking at our types. So we definitely have an esterification because we made an ester. So that was one of your types of reactions here, the reaction of an acid with an alcohol to form an ester. Because we also produced water, so let's put the H2O in here. It's not a dehydration because we synthesized a compound, so it's a dehydration synthesis, which is condensation. And it's also an elimination because we eliminated water between our acid and our alcohol. So that's number 12 completed. The next one we're going to look at here is number 13. So for 13, what we have now is an alkaline hydrolysis of isopropyl, where are we here, pentanoate. Okay, so what are we doing here? So isopropylpentanoate is an ester. And what we want to do is an alkaline hydrolysis. So we're going to cut, but instead of cutting with water, we're going to cut with an alkaline substance, which is NaOH. So you can do a hydrolysis of an ester by adding water to create an acid and an alcohol, or you can do what's called an alkaline hydrolysis, which is the soap making process, saponification, where we add an inorganic base to it. And so what we make is not an acid and an alcohol, but what's called the salt of an acid, because it's going to become ionic, a salt of the acid and the alcohol. And the salt is what makes the soap. So if we were to draw this out, here is our isopropyl pentanoate. And what we're going to do now is we're going to add NaOH to this. And according to your chart, when you add NaOH, you do need high heat. So I'm going to put that on here. Okay, so here's what happens, is your NaOH is going to come in, and this time you're going to break the bond after the O, not between this C and O, but after the O. And when you do that, what happens is this O now has a free electron on it, so it's going to form a negative charge. We know that sodium hydroxide, being ionic, is Na plus and OH negative. So what happens is this open bond on the O, that's an unpaired electron, so it carries a negative charge. It's going to attract the Na. So the Na, it's not a covalent bond, it's an ionic bond. So this is your nonpolar end of your acid that you started with, and now we have a polar charged end, negative and positive, and this is what makes soap. So this is called a salt of pentanoic acid. We didn't actually make pentanoic acid, we made a salt of pentanoic acid, and this is your soap with your polar hydrophilic end and your nonpolar hydrophobic end. And so now what happens is your alcohol, this carbon has a free electron on it. It has a free electron on it, but because carbon is not a metal, it forms a covalent bond. It's going to pick up the OH and it's going to share covalently. So what you've made now is an alcohol. You now have isopropanol. So when you carry out an alkaline hydrolysis, you make a salt of the acid, and most of them are what's called fatty acids. They're 4 carbons or longer. That's what your soap is a big long fatty acid that has this polar end to it. And that's why it's called a salt of pentanoic acid, and you get an alcohol. If you were adding water to this, you would just get pentanoic acid and isopropanol. But when you add the base, because the base is ionic, whereas water is covalent, you get a salt, and this is your soap. Okay? So in terms of types of reactions, we have a saponification. Okay? We also have an addition, because we added an Na and an OH that were not there before. And because we've broken this bond and synthesized 2 smaller ones, it's a hydrolysis, but because we use sodium hydroxide, it's referred to as an alkaline hydrolysis. Okay, so these are really the same thing. I didn't need to write them out twice, but I want you to be aware that those are the same thing. Okay, the last one that we're going to do, that I'm going to do with you here, number 14, is now we're going to do a hydrolysis, because you cannot do an alkaline hydrolysis on an amide, but you can do a normal water-based hydrolysis on an amide. So hydrolysis of N-butyl propanamide. So it's the exact same process as we did up here, except instead of using sodium hydroxide, which is an alkaline substance, we're just going to use water. So you have to recognize that's an amide, 3 carbons, and then you have a butyl group off of that. So that is your N-butylpropamenide. So what we're going to do is we're going to react it with water. And remember, water is H with an OH. Whenever you carry out a reaction with water, you need concentrated H2SO4 as a catalyst. So what we're going to do now is, this is a little bit different, is we need to cut here because we need to make an amine and we need to make an acid. Here's why. Because to make an amide, you need an acid and an amine. Well, when you break an amide, you create an acid and an amine. So that's why you have to break the bond in here. So now on the other side, we're going to put the OH from the water here, and so now we have propanoic acid. And then we're going to take the H, because normally we would have H here, we have to add an H to that. So we're going to add that H here. And now we have butane 1 amine. So we carried out a hydrolysis, a normal hydrolysis. And we also have an addition because we added an OH and an H that were not there before. Okay, so that's what that reaction looks like. So you can also carry out a hydrolysis on an ester doing the exact same thing, adding water. You make an acid and an alcohol. When you undergo hydrolysis of an amide, you make an acid and an amine. You can undergo an alkaline hydrolysis only with esters, and that makes a salt of one of these acids, and that's what your soap is. Okay, so here's your job now, and this is going to be posted in Minds Online. Number 15 and 16 are full-length pathways. We've done every step on this chart in chunks. Your job now is to put it together. So in number 15, you're going to start with an alkane, and you're going to make phenylethanoate. So you have to recognize that that's an ester. And ethanoate, your parent is 2-carbon. So you're going to start with a 2-carbon alkane. You're going to make an alkyl halide, so you can pick whatever halogen you want. Make an alcohol. You have to head down and make an aldehyde into an acid, and then to make your ester, you add an alcohol. So what alcohol do you add? You go back to the question. It's a phenylethanoate. So you're going to add your benzene-based alcohol, and you should know how to name that. In number 16, you're going to start with an alkene. So you're going to start up here, and you're going to make an amide this time. So you can either go down here and across, that puts in an extra step, or you can start here, go straight to your alcohol, straight to your aldehyde, your acid, your amide. You have to add an amine at the end, and when you go to the question, you're adding a 3-pentyl, so you're going to be adding a 5-carbon based amine when you get near the end. Make sure you put in all your conditions and make sure you label all the different types of reactions that occur. Okay, so the answer key to those two will be there. All of this is going to be uploaded into Minds Online, and your job is to go through them and finish these 2, and then you've got 9 of these on your test review to work through. Okay.